What is the formula for the compound composed of 71.62% gold, 13.1% carbon, and 15.28% nitrogen? Is it A. AuCN, B. AuCN2, C. AuCN3, or D. AuCN4? In 100 grams of the compound, there are 71.62 grams of gold, 13.1 grams of carbon, and 15.28 grams of nitrogen. The formula gives us the ratio of the number of atoms. It also gives us the ratio of the number of moles. To figure out the formula, we need to convert these masses to moles. To convert masses to moles, we divide by the atomic mass. From the periodic table, we get the atomic masses of 197.0 grams per mole for gold, 12.01 grams per mole for carbon, and 14.01 grams per mole for nitrogen. So to figure out the number of moles of gold, we multiply 71.62 grams of gold by 1 mole of gold over 197.0 grams of gold. We have a number with 4 significant figures divided by another number with 4 significant figures. So our answer should have 4 significant figures. Grams of gold cancel, leaving us with moles of gold for our units. This gives us 0.3636 moles of gold. Next we do carbon. Multiplying 13.10 grams of carbon by 1 mole of carbon over 12.01 grams of carbon gives us 1.091 moles of carbon. For nitrogen, multiplying 15.28 grams of nitrogen by 1 mole of nitrogen over 14.01 grams of nitrogen gives us 1.091 moles of nitrogen. We now need to convert these numbers of moles to the simplest whole number ratio. To do that, we divide each number of moles by the smallest number of moles. The smallest number is 0.3636, the number of moles of gold. Dividing 0.3636 by 0.3636 gives us 1, while dividing 1.091 by 0.3636 gives us 3. So for each mole of gold, we have 3 moles of each of carbon and nitrogen, giving us an empirical formula of AuC3N3. There is an ion with equal amounts of carbon and nitrogen, Cn, with a charge of -1, the cyanide ion. So we can change this formula to AuCN3. So the correct answer is C.